This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Hi, everybody. Not is on yet, so I'm going to go ahead and share my screen. And it is Wednesday, August the 7th, and we are on lesson 2 from the math map, and we're going to be working through the complex. So please go ahead and get your booklets out. If you have the complex booklets, that's great. You'll be able to follow along with all the pages. If you are in another domain, pay attention to what is on the screen for the pages that were not included in the digital version. But when it comes to the lesson pages and the concepts, we are all talking about the same thing, no matter which domain that we are in. So let's go ahead and start with our math map. And we are, if you notice here, we're giving some prompts each week for the first few weeks of a blank page. But to start off by reviewing our lesson. So we are in number notation. So we're going to be working through this row right here, number notation. We are still in 0D. And you want to go ahead and find the domain that matches. So if you have the complex booklets, you are in here. It is gold on your cover on the left-hand side. It will say C, complex. If you are in fractions, you will have green pages and it will have a green bar on your cover and it will say Q, fractions. If you have the naturals, it will have a red for naturals. And if you have the, it will be purple and we'll say N digits. So go ahead and make sure you know where you are. We will all be in this row, but depending on which domain you are working in, you're going to go ahead and put your check mark there. All right, so now let's go ahead and take, we're going to take 2 minutes to play our national number knockout. So I'm going to start our timer and you can go ahead and either take turns saying them or put them in the chat box, and I will do my best to keep up and knock the numbers off. So our numbers this week are 5, 3, and 1.
5 squared is 25 plus 3 plus 1 is 29.
5 times 3 times 1 is 15.
5 plus 3 plus 1 is 9.
5 minus 3 minus 1 is 1.
5 squared is 25 plus 3 squared is 34 plus 1 squared is 35.
5 minus 3 times 1 equals 2.
You took it from me. 5 times 3 is 15 plus 1 is 16.
5 plus 3 is 8, minus 1 is 7.
5 times 3 is 15 minus, oh, we already got Nicole.
Trying to keep up with the chat log.
Oh, 5 minus 3 is 2 plus 1 is 3.
3 cubed is 27 plus 5 plus 1 is 33.
5 to the 0
Don't even try.
is 1.
Try. I said, try. Put it down.
3 squared is 9 plus 5 to the 0 is 10 plus 1 to the 0 is 11.
All right, good job, everybody. Way to wake up our computation brains. And I just want to point out there, I didn't say our math brains because not all of math is a computation. So computation is an important part of math, but it is not all of math. And so we want to help our students see that that if they're good computers, they
Good point, Alpha.
exercise their brains where they're not computing to see patterns and to see other mathematical truths. But if they're poor computers, that is a skill that they can develop over time. And there are still a lot of things that are available to them to explore in mathematics. Let's go ahead and move on to talking about our cover. So I'm going to go ahead and start our timer. Keep us on track. And let's go ahead and share what we see in our picture this week. This is the Apple Harvest by Camille Pissarro. And I'd like you to think about why was this chosen? So you may want to think about the domain. What might this tell you about numbers? How could we see some numbers in this? And then what other things do you see that you'd like to discuss?
This technique is pointillism, where the picture is made out of like just a whole bunch of tiny little dots. And that makes me think of zero dimension because dots represent points. And so that's a fitting type of artwork.
That's great.
One thing that my son and I, when we looked at this over the summer, that we had talked about was if you just take one of the dots or one of the points, and you just had that by itself, that it wouldn't be very beautiful. It really wouldn't mean anything. It would just be a little point or a little dot, and that it really takes all of those things put together to see the full picture. And so as we were just beginning the math map, it was kind of that idea of you may not see the whole picture now, but when it's all put together, when we finish, or we get through the 30 weeks, then we can look back and see this full picture of what we've really accomplished and not so much focused on that one spot where we are.
That's great.
So it cut out for a minute, so I'm sorry if I'm repeating what someone else already said. And I don't know if you can hear me. It looks like it froze again. What I see in the artwork itself, it looks like they are harvesting some sort of crop, whether it's apples.
Yep.
Or pears. And so they're going to need to record in some way the amount of things that they're gathering. And so some way of notating their numbers to keep track of what they're getting from the tree there.
Excellent.
In the chat, Kirsty Wilder says there are shadows in the back that remind me of a number scale with 0 in the middle.
Ooh.
So as I'm looking at it, oh, go ahead.
A type of measurement, when you pick apples, they use bushels and pecks, and that is something that we don't usually use nowadays. So something that we could talk to our kids about.
So as I was looking at the points, it looks like there's a very limited number of colors that the artist is using. Probably just the 3 primaries. It looks like maybe white. And it's just striking how creative he got with just those 3 or 4 colors.
I'm reminded that this tree was grown from one single seed, but there are many fruits that have come from it.
So kind of piggybacking off of the comment where they're harvesting fruit, I think of the receptacles that they're using and thinking in terms of capacity of each one based on the volume that they hold.
Great.
And they're working together. And I think if it wasn't for my friends, my understanding of math would be much less.
I really like that because we grow up with our conventional educational system teaching us that math is a solo pursuit.
Yeah.
And you've got to take a test and do your homework and don't copy. And that's not mathematicians' work. Mathematician as a subject, schooling is very collaborative. And so I like that. That it's something where it's going to be much better if we work together.
Yeah.
I'm not really sure how it's mathematically significant, but just hearing some of you talk about the individual points coming together, this one tree appears like it's very far. It's pretty separated from the rest of that orchard. It's still a part of a larger orchard that's obviously going to produce a larger crop, but it's quite a distance away. And yet all 4 of these harvesters have come over to where this particular tree is. So it stands apart, but it's still part of the whole.
I like that.
It's not the main focus, but I'm thinking of my younger learners who would probably say there are angles and shapes. If you look at the back, you can find a circle on the cart. And then you can say you see the different angles in the trees, and you can even talk about the distance of near and far and the curved lines versus a straight horizontal line, but we're still representing the horizon.
Good. And speaking of our younger learners, how many gatherers are there?
4.
4, right? Could we count the trees that are in the background on the hill?
Yes. And the baskets.
And the baskets, right? So there's a lot of things that, I really want to encourage us because we are all looking at it through the eyes of adults, and we're going to probably go a little bit deeper. But with our youngest students, it's okay to talk about, let's just count, right? It's a week about numbers. Let's count. What things could we count?
On that note, you could use that group of 3 to the left and the one on the right as a subtraction or addition problem.
Absolutely. That's great. All right, Donna Liber, you read our quote for us this week.
Nothingness Obeys His Voice by Richard Swinson.
Excellent. So whose voice are we talking about?
God.
So what do you guys think of that nothingness obeys God's voice?
You spoke and it became. Everything from the void, he spoke into it, and here we are.
He controls everything.
Yeah, I love that reminder, right? That there's nothing that is outside of his purview, right? There's nothing outside of his. Carrie, would you read our reflection this week?
Sure. O Lord Jesus Christ, unveil mine eyes that I may comprehend the wonders of thy laws. Tell me the secret and hidden things of thy wisdom. O my God, I trust that thou wilt illumine my mind and comprehension by the light of thy reason. St. John, how do you say his last name?
Chrysostom, I think.
Okay.
Why might we have chosen that, or what does that maybe mean to you from the context of 0D of our first lesson where we're really diving into numbers?
When I think of comprehending the wonders, I think about focusing. And with the zero dimension, I think we're just kind of focusing on like one thing at a time. So maybe as we comprehend the wonders, our secret and hidden things, we're focusing like maybe on one thing at a time.
Well, that's good.
I also feel like it's just reminding us where our focus needs to be, which is on the Lord, and asking Him to give us what we need to look at this. Like, that's where we want to start in our learning process, is like, how do we honor you? Well, we come to you first.
Good.
It reminds me of the glory of God is to conceal a matter, but the glory of kings is to search things out. That there's things that we sometimes even forget to think about, like nothing or a zero or a point, that changes everything when you really let your mind go down that trail. And we need God to open up our eyes to see all the things that we haven't even thought about yet.
That's great. Especially these early lessons where it may feel like it's really familiar. I know what there is to know about numbers, or I know about addition and subtraction, right? And so that reminder, I like that reminder. There are still things for us to discover. All right, well, we're going to turn to our I² invention page. And just a reminder that that I² invention page is there to give us where we can emphasize modeling the 5 common topics with our students. And so as we look at this page, one of the questions that Leigh encourages us to ask every week before we jump into those 5 common topics is, tell me everything you know, right? So during this part of our class, we want to help students realize that they maybe know more than they think they do. So go ahead and tell me everything that you know about numbers. And you can use things that are on this page, but you don't have to, right? We're going with the, our title this week is number notation. So just tell me everything that you know about numbers.
There are different kinds and types, and you can manipulate them in many different ways.
They are a symbol.
They are sequential.
There's infinity of them.
They can be categorized into different domains.
Even though there's infinity of them, there's only 10 symbols for them.
Numbers are symbolic and represent something else.
Numbers are different than numerals.
Good.
You can have portions of numbers, fractions, and decimals, and you can write them different ways. You can write the same number multiple ways.
Good.
Sometimes letters represent numbers.
There are different bases of numbers that are used for different purposes.
Okay.
We can use them to form patterns or recognize patterns.
Numbers have an order.
They're present everywhere.
Was it Plato who said all is number?
Good.
Okay.
So just to clarify, because several of you said similar things, so I'm just going to clarify, and then this may give you another place to go with what you know. right? So number is an abstract idea of a quantity, right? And then we have the notations of all of those different numbers, and we can have multiple different notations of those numbers, and those are concrete. So we have the numeral 3, right? But we could also have 6 divided by 2, or we could have 3 tally marks, and those are all representing the same quantity. So just to clarify that difference between number and notation, or between number and numeral, does that make anybody else think of anything?
Some numbers are completely abstract and out of like I. So it's something that we cannot have we don't necessarily have a number for the actual, there's no quantity.
What are some of the domains? So somebody said we can classify our numbers into different groups or different domains. So think back to our math map. What are some of the domains of numbers that we could use to classify them?
Digits.
We have
naturals,
rationals, integers,
Transcendentals.
Complex.
reals, fractions, transcendentals, monomials,
Irrationals.
binomials, polynomials.
Good. So we can represent our numbers in lots of ways. We can classify them. So we know quite a bit about numbers. 10 numerals that we use to represent all of our numbers. What are those numerals?
0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Good. So we all have a starting place of kind of what we think of number. So that's what we're going to be working on this week. So let's go ahead and look at our Memoria page now. And remember that this page here, both of these pages are going to be a reference for us this week or in other weeks, because they're pulling ideas oftentimes from multiple weeks. They're going to pull some ideas together that are related. But when we're on our Memoria and arrangement page, our emphasis is on what are some things we could memorize or add to our Memoria? What are some patterns that we could notice, right? How does the arrangement help? Look at the top of our Memoria page here, and you notice.
Starting with place value.
Okay.
In different bases. So we are doing different bases.
So what are the 3 different bases that we're looking at here?
10,
Base 10,
2,
base
and
2,
3.
and base 3.
Good. What other pattern do you notice here?
So the exponents on all of the bases on where it says value, whatever the base is, the exponents follow the same pattern.
Excellent.
What did you ask? What is the pattern?
Yes.
Yeah. Okay. Well, there's different ways of looking at it, but it's starting at like the radix or the decimal point. Like to the right, it's -1, -2, -3, -4, and to the left, it's 1, 2, 3, 4, 5, increasing.
Good.
Or 0. I forgot the 0. 0,
And
1,
looking
2,
at looking at base 2 and base 3, when you're looking at the place to the left of the decimal point, the radix point, it goes up by multiples of that base.
Oh. Good.
One thing I noticed that may or may not be helpful is that the exponents go in an opposite order of what I'm used to seeing on like an X and Y axis. So, you know, it's in from the radix point, it's, you know, it's increasing from there, but it's actually decreasing, you know, when I read it like I would normally read. So that's something I observed.
That's good.
Christy, Ashley Bruner says in the chat, I'm not a math person and I have a feeling I will hear from my students. When will we need to use base in real life? I have no idea how to answer that.
So, so one thing that's true is that not all of mathematics is used in our everyday life, right? Necessarily walk around thinking of things that, but there are understanding how bases work. First of all, it helps us to understand how all of our numbers work. That idea of place value and bases is going to help us to connect like polynomials to how our numbers are built. But then also, if your students were to continue on in their study of math, for example, there's actually truths about mathematics that we can only see when we look at numbers expressed in different bases. And base 3 is an example of that, where get into it, but there's whole sets of numbers that when we look at them in base 3, there's patterns that emerge that we would not see if we were looking at those numbers in base 10. So it may feel like there's this sort of trivial idea behind understanding the different bases, but just like everything else we're talking about, where we're talking about seeing the unseen, understanding how to express numbers in different bases and then eventually working with those numbers in different bases are going to help us to see things that maybe were hidden when we were looking at numbers in base 10. And the reality is that a lot of us actually do in different bases, right? If we think about time is kind of an odd thing because it's like this mishmash of bases, because I don't count my seconds in groups of 10. I count them in groups of 60. And once I get to 60, well, right, I get to 59, and then I don't go 60, I go 1 minute. And then if I count my minutes, I get to 59, and instead of saying, well, 60 minutes, I go, oh, that's an hour. And then my hours now don't go in groups of 60 anymore, right? Once I get to 11, my next hour goes to 12 if I'm on a using AM or PM, or I get to 23 and then my next hour is 24, right? So now I go to 24 hours to 1 day. And then if I was thinking about years, right, up to 364, and then once I get one more day, I end up with a year, right? So we all use different bases all the time, even if we're not necessarily setting it up like we see it here on this chart. But understanding the order of this chart, right? Understanding how numbers are ordered together is going to help us just to understand numbers in general. By comparing base 10 to base 2 to base 3, we're going to come back and we're going to go, oh, there's a pattern. I see what the pattern in base 10 is. And I maybe wouldn't have seen that if I hadn't compared it to base 2 and base 3. So we are on the Memoria page and we've into some patterns. What might I memorize? Do I want to memorize that example, the example digits in the middle?
Probably not those exact digits.
Not those exact, right?
Looking at them, it looks like, is it true to say base 10 uses 10 digits to express its numbers, base 2 uses 2 digits, and base 3 uses 3 digits?
That's excellent. Is that something worth memorizing?
I think so.
Yeah, right. So those are the kinds of things that we want to do on this page, is we want to encourage our students to attend and look for patterns. We want to encourage them to look for things that maybe are worth memorizing, or how can I build? And here's how I differentiate between memorize and building my memoria. When I say memorize, I want something to be exact, right? If I'm memorizing the quadratic formula, I need it to be exactly the quadratic formula. If I'm adding something to my memoria, I might say, well, that radix point, my numbers are getting more negative to the right and are getting more positive as I go to the left. that's different to what's here because I put it into different words, the same idea that I'm feeding into my memoria. And so that's maybe not something as a tutor, I would have that conversation in class with my students all the time. But as parents, that's how we can help our students to sometimes see there are things that I need to memorize verbatim and exactly the way they are. And there are other things that sometimes restating it will help me build my memoria, even if it's a little bit different to what I see in front of me. So that's our memoria and the arrangement. So let's go ahead now and take a look at our charts. And for our book club, our goal is to look at our charts and just to identify what are some things that are familiar or some things that maybe are unfamiliar. So let's start with everybody trying to find at least one thing on these pages that's familiar.
Integers.
The Euler diagram.
Fractions.
The number descriptions. The expanded math map domains.
Where are those colors of the expanded math map domains? Where are those you're from?
On the math map front page,
The
and
map
every booklet along the top of the math map page.
If this is your first time in the math map, is the Euler diagram necessarily going to be familiar?
No, it wasn't familiar to me.
How about on our second page of the charts, as we look at those number, which of those may be familiar to you?
The different types of numbers, so numerals, cardinal words, ordinal words.
Is there anything in those numbers, those number representations, that top section, is there anything in there that is maybe unfamiliar?
The transcendentals, the way that's notated, and the irrationals even, like, so I noticed the rationals is with a Q, and irrationals is also with a Q, but then there's that little C up there. That was very confusing to me this week, so I did a little research and had a little moment of illumination.
What did you discover, Jana?
Well, I discovered that it's talking about a universal set, every number that you can possibly think of. So it's that C up there is a complement to it's all the things that aren't rational. So the Q still stands for rational, but the C up there is saying everything else that completes the universal set of numbers. Is that right?
Yeah, that's exactly it. So the complement, and right, when we think of object complement noun, so if you've been through essentials, right, what does that complement do? It's completing, right? When we talk about those, that object complement, it's saying it's completing that idea. So a complement is a complete, and that's exactly the same idea, that when I'm talking about sets, my complement, what is it that completes? So usually it's the things that are not, right? So when I see that, the set that's going, what's going to complete the set of real numbers? Well, if I already have the rationals, it's everything that's not rationals is going to complete it, and that's my irrationals. So excellent.
Okay, we have a few questions in the chat. Yatin is asking if the chart should be reviewed prior to lesson page 1. And then Tanya asks where and when should you ask about these questions on the charts, and is it related to the student work on page 15? And the page and the companion information for C2, 3.
So
looking at
just a
C2.
reminder, right, that the charts are the same for every domain. So I spoke with somebody earlier today and they needed that confirmed. So in case anybody else does, those charts are the same whether you're in naturals all the way through our curriculum. And they're colored blue. That's our transcendental color, that transcendental blue, because they represent our goal, our full scope of math for our students to be familiar with by the time they are finished with the math map in 4. And so notice I said familiar. We're not promising that anybody's going to master everything on these charts, but our goal is that as we become more fluent in the language of mathematics, we're going to be familiar with the ideas that are on these charts. We may master some and we may understand well other things, but our goal is to be familiar as we're building that language. So these charts are included in each lesson as a reference. So you, in community, just like we're doing today, notice that one of the things we're doing is we're going through and we're just saying, hey, what's familiar, what's unfamiliar, just so we're familiar, again, familiar with what's on the chart and where things are. Then we can go back and use those as a reference for our lesson pages. So let's go ahead and take a look at our lesson pages, and you may go, oh, I remember seeing that on the chart. But before we move into that, each week, this is when our tutors would pause for just a moment and see if there are questions from the previous week. So are there questions from lesson 1 that you have that you would like to have asked before we look at our lesson page tops for this week? All right, so each week we will have this pause so that if you encounter something in your lessons and you're like, well, I have a question about that, this will be the place where those questions. All right, so let's go ahead and look at the top of page 1. So whatever domain you are in, I would encourage you to look at the top of page 1 in your domain, and you'll see that it's going to be very similar to what you see here from the complex lesson. And the first thing that we always want to do is we want to read our instructions. So I'm going to go ahead and read for us. It says to complete the sentences. So that's just telling me I'm going to be filling in the blanks. So 0 dimension, 0D is represented by a point. A point is that which has. Does anybody this? Is this in anybody's memoria from last week or from other places that we've been looking at?
Length,
Depth
width,
or
or
length.
depth.
So we've got, I might go in a different order to you, but length, width,
Depth.
height or depth, right? So we use height. So that's my point. It has essentially no measurement. All right, underneath that it says, except for unary, that's base 1, tally marks, 0 is a digit in every base. And now let's use that as a model for our next line there. What do you think we're going to fill in our blank with? 1 is a digit in every base. Excellent. Below that, we have a blank and it says 0 is a blank. And we're given a hint here because anytime we write one of our number sets, we're going to write the symbol for that set afterwards. So what symbol is, or what set is that N a symbol for?
Naturals.
Natural. So 0 is a natural number. And then our last line says 0 plus 0i is the complex form of
0.
0.
I have a question.
Yes.
So I don't know if this was in a previous book club conversation that I heard. I don't know where, but can you give me a little bit more background on why 0 is specifically defined as a natural counting number in MathMap? Because I know there's debate on that, and
Sure.
I've seen it as it comes in integers, where we introduce the opposite of numbers and the origin. So can you just give me a little bit of background as to
Sure.
how it
So
benefits being defined that way?
Sure. So it is in the wider mathematical community, it is something of, I don't even know if I want to say debate, but it is something where people have to really define their terms, whether 0 is included in the naturals or not. Because we wanted to be able to set up our Euler diagram and see those subsets of numbers and help to see that the digits are a subset of the naturals, 0 needed to be a natural number. So it's a very practical reason that we wanted to be able to say, yes, look, there's this nice set of numbers and our digits are a subset of the naturals. If we didn't include 0 in the naturals, it would break that pattern up. And so that's really the practical reason why we're including 0. But we're very, very clear to define our terms. And that's what I would encourage anytime you're looking at a curriculum, is to just be really clear. How is it that they're defining, or any math thing, how is it that they're defining in this case? And so you'll notice that there will be times, because we want to exclude 0, that we will define a set of numbers as the naturals greater than 0 or greater than or equal to 1.
So 0 is defined as a natural number in MathMap because we want to show that it is a subset of what? Did you say that again?
So that the digits 0 to 9, so that those digits can be counted as a subset of the naturals.
Okay.
All right, so now let's look at the right-hand side where it says to write the domains in the Euler diagram. And so at the top, as we read this, it says complex, and then we're given the form a plus bi. Underneath that, our complex numbers we have 2 boxes. To the right are imaginary numbers, and so we see I cubed and the square root of -1. Blue box has an R, and what does that R stand for?
Reals?
Reals. If you didn't know that, you can go back and look at your chart. You can look at your math map along the top. You can also go and look at your solutions. We really want to encourage you to remember that the solutions are a great way to work backwards. So below that are our reals. Then we see our irrationals are on the right-hand side, and that's the square root of 7 and phi are given as examples. A subset of the irrationals are our transcendental numbers, and we're using pi and e as examples. If numbers are not irrational, right, we just talked about this, they must be what? What does that Q stand for?
Rationals.
Rationals. And I heard somebody say quotient, and that's exactly because a rational number is a number that can be written as a fraction. That is a quotient, and that's why we use the Q, because the R was already used for reals. All right, our rationals, a subset of our rationals is what is our pink box with the Z?
Integers.
Integers. And then those are our negative and our positive numbers. And then our positive numbers are, what did we say the N represented?
Naturals.
Naturals. Let's go ahead and look at page 2.
The Whitehead family asks, why are irrationals different than other subsets? Irrationals.
Oh, like they don't have a box? Sure, because I can have complex numbers. So for example, 4 plus 3i is a complex number. It's not real and it's not imaginary. It's just complex. So within my complex numbers, I have numbers that are either fully complex, real, or imaginary. Those are subsets. With my reals, the irrationals and rationals are subsets, but everything that's not rational is irrational. There's no real number that's or irrational, if that makes sense. So when I look at that, that's why we didn't put it in its own box, because we wanted to be clear that there is no other kind of real number. It's either irrational or it's rational. All right. Looking at page 2, what chart does this look familiar to? Does anybody remember?
The chart on the chart 2 for this week.
Yep, that chart that we were just looking at, and people said, oh, those cardinal words and tally marks, those feel familiar, right? Looks like. So let's look, and it says to complete the table, and it says crossed out boxes do not require equivalent form. So when we look at 0, some words for 0 include 0, not, or cipher, but we're not going to talk about tally marks or Roman numerals, ordinal words, or ordinal symbols. So for 1, our cardinal word is 1. Tally mark. Our Roman numeral is I. Our ordinal word would be first, and our ordinal symbol the small st. Now let's use that to help us fill in our next row. So 15, of course I said it, what's our cardinal word for the numeral?
15.
15. What would our tally marks be?
It would be 3 groups of the 4 with 1 crossing through.
So 5, 10, 15. What would our Roman numerals be?
XV.
XV. And how would I write the ordinal symbol for 15?
The numeral 15 with the TH.
Good. Now we're writing them here with the ST and the TH as a superscript. If you have a student who wants to write them full size, that's okay. Right, both are correct. So let's look at our next row. What's the cardinal word for this numeral?
20.
20. What would be our Roman numerals?
XX.
X. Yeah, correctly.
We have a couple of questions. Jackie is asking why is there no ordinal word for 0 on page 2, but chart 2.2 says the ordinal word is 0th. And Heidi asks, why do we not fill in ordinal word symbols when it shows them on chart C2?
It's so there are going to be times where there's going to be things that are on the charts and we're just not practice them on the lesson pages. And a lot of that is just as Leigh is trying to make the lesson pages really accessible to students. Pull out some of the things that maybe are more familiar for students at this point, and then add things in over time. So what would our ordinal words for 20 be?
20th.
And our ordinal symbols?
20 with the TH.
Okay. So we're not gonna finish this one here today because I think you guys get the pattern here. So you can go ahead and complete that at home. Let's look at page 3 together. And we're told to complete the entry basis table. So on the left-hand side, we have the name of our bases. We have binary, ternary, quaternary, and decimal. Then we're told we have base N, base 2, base 3, base 4, base 10. So we're given some notation here. Then we're asked the number of digits. So how many digits? So notice in base 10 we had 10. So how many do we have in base 2?
2.
2. How about in base 3?
3,
3. And in base 4?
4.
4. Sorry, I didn't wait. And we see that our set of digits in decimal goes from 0 up to 9. What would our set of digits be for binary if we only have 2?
0 and 1.
0 and 1, good. And so you can go back and remember on our first page, we said that 0 and 1 were both digits base. So we know that every base has to have 0 and 1. So how about ternary? We just said it has to have 0 and 1. What other digit does it have?
2.
2, good. And how about quaternary? It has 0 and 1. And what other 2 digits?
2 and 3.
2 and 3, good. And we see the hopefully that we're building there. All right, on the right hand, to write in decimals. Decimal means we're talking about base 10. Those are the numbers we're most familiar with. And we see here we have 8 and 1/10, which is the numeral 8, a decimal point for the and then 1/10. So how would we write 45 and 3/10?
4, 5, decimal 3.
Good. Next, we see we have 6 and 500. So we have 6 and our decimal point 500. So notice now I have a 0 for my tenths and my 5 is hundredths. So how would we write 11 and 300?
11 decimal point 03.
Good. And then we're told that 66 and 1/10 repeating is written with 66, a decimal point, and a 1, but now we have a bar over that 1. And that's what means repeating. So how would we write 51 and 5/10 repeating?
5, 1, decimal 5 with the bar over the last 5.
Good. So notice here that even if I'm not really certain about how to write these numbers, we're looking at that example and we're using that example to help us to complete the exercise, to write the next one down. And page 4, as we come to page 4, we are asked to label the parts of our set notation first. We're told that the squiggly lines are braces. What are the X1, X2, and X3? Anybody know what those are called?
Elements.
Elements, excellent. And again, you could look at chart 4, or you can look at your solutions manual to help you when you're not sure. And then what are our 3 little dots there called?
Ellipses.
The ellipsis. Good. All right, next we're told to read the sentences aloud and read the equivalent set notation. So I like to point to the symbols to help me figure out what words and symbols go together. So as I do that, I have the set. So that's telling me I'm using my set notation, my brackets, of all X, there's my X, such that, there's my bar, X, there's my X is an element of, there's my element of symbol, the naturals, and there's my N. And so we would just be copying, and we could even read it again as we copy it. So I have the set of all X such that X is an element of the naturals. The next line says that X is an element of the real numbers. So as I copy, I have X is an element of the real numbers. A is the empty set. A is the empty set. The universal set is the union of A and B, right? My universal set is the union of A and B. And the complement of set B is set A. There's my complement, what we've talked about. So the complement of set B is set A. The cardinality of set B is 1,289. The cardinality of B is 1,289. And set A is equal to the intersection of B and C. So I have set A is equal to section of B and C. So notice we're not trying to define or necessarily understand. We're truly reading and then copying the notation, and where we're able, we can connect those two.
This is a super helpful thing, by the way. I love this because I feel so empowered. Like I see that column that has all the symbols and it makes me feel panicky. And then I love that it's written in plain English how to say those things. It's empowering.
Yay. All right, so as we come toward the end of our class, we're going to go ahead and we're going to work through our resource reminders. So you guys say the orange, and I'll ask the questions in black. So what are the solutions for?
To check
work
and
work backward.
Good. What is the inside back cover for?
To extend the conversation
and fill the
lesson
lesson 29
booklet.
What is the back cover for?
To play games.
To play games.
What is the careful calculations page for?
As a
The
review
or
or
test.
What are the flashcards for?
So I can
So I
I can read math.
What is the math map companion for?
So
my
My
parents
parents
can
can answer my questions.
And what are the lesson pages for?
to practice
Practice math concepts.
Excellent. All right. So just as a reminder of the helps that you have the companion, the forums, you have your community and tutors and email. I do want to just mention, if you are a Challenge Day tutor, just remember that you also have access to our curriculum assistants and their live help desk. You also have access to the authors of the Math Map, me and Leigh, when she's available to ask math questions. So if you are a Challenge A tutor, I just want to remind you that you have access to that. If you are a Challenge A parent and you have questions, right, notice that your tutors have access to information. So they are your best resource because if they can't answer your question, they can get an answer for you. Don't forget, we have the archive of the book club, and we put there our original book club emphasized the exordium and the charts. Our naturals book club this spring was pages 1 through 4 of each of those naturals lessons. And we did a lot of what questions could you ask. We then had our summer book club where we looked through at the different dimensions, some big questions and the quadrivium. And now we are using our in-community outline as we go through the complex books this academic year. So next week we will be talking about comparison and then each week that. And so we have a couple of minutes for general questions.
So Kirsty, I had a really I have like an like what is it, like a preschool question. So like when we're trying to write the symbols for all the number sets, it's like there's like a lot of double lines. Like, is there a standard way of handwriting that is easier than like trying to copy every double every way?
Sure. So I mean, I usually, oh dear, I didn't mean to do that. Let me see if I can go back. Let me turn my pen on. So for the naturals, I usually just do my left. And so I just make 2 lines. My integers, I draw my Z and then I double the middle line. For Q, I make my Q and then I just draw a line on the left.
Okay.
For R, again, a double line and finish my R.
Right.
And C, I draw my C and I draw my line on the left.
Okay. And so the A, would you do it on the left as well?
I would,
Like
yeah, I would
double
just
on the
do
left?
that double
Okay.
line. Yep.
Okay. All right. That is so helpful. Thank you. I was like trying to like, okay, I know I can make it really artistic, but that's going to take me more time than I think I feel like I
Yeah,
have.
no,
So thank you.
remember, mathematicians came up with these, so they're not intended to be, they should be quick and efficient, not necessarily artistic.
Great. Thank you so much.
Oh, you're welcome.
Is there a place that gives us resources for directing parents of what to do at like how this looks at home and how much hands-on the parent should be versus how much freedom the kids should have?
Sure. So that's really going to depend on every family. We have in the companion, if you're in the companion page, you can click on notes and that will bring up some general information. And there's a section in there about tailoring, which may help give parents some ideas of different ways to approach this at home. We also have, and I don't know if Shauna knows which one it is, but you can always email the mathmap@classicalconversations.com and they can get you the link. But one of our book clubs this summer, I think was really helpful in terms of helping to lay out what that may look like at home, especially with multiple ages. So that's probably one of the better resources is that book club episode. And then again, using the companion.
I think it was the first one this summer for the 0D.
Thanks.
I have a
My
question
underst-
on, oh, sorry.
Go ahead.
Okay, sorry. I have a question back on page 1, and this may be, I don't know if I've missed something in charts, but top of page 1, the right, where it says write the domains in the Euler diagram. So in the irrationals in that set, we're showing square root of 7 as irrational and phi, the golden ratio, as irrational. But then under it, we've got a purple box for the transcendentals. I'm assuming the irrationals, I know the irrationals are all square roots of numbers that are repeating and not ending, and they don't truncate. Are the transcendentals there, pi and Euler's number, are those the two transcendentals? And why are those in a separate,
Sure.
not shown as irrational?
So they are irrationals. They are a subset of the irrationals. So that's why they're in that irrational. They are a subset of the irrationals. And there are actually more transcendental numbers than there are other numbers. There's so many of them. These are just two that we're looking at. But there's, if you look on chart 1, you'll see there's a definition for algebraic numbers, and a number is either algebraic and transcendental. And if it's transcendental, then it is never going to be the solution of a polynomial, a certain polynomial. And so that's how we define that. So we don't necessarily need to go into it here, other than understanding that the transcendentals are actually a subset of the irrational numbers. So not every irrational is transcendental, but pi and e are two examples that are.
Okay, so what chart did you tell me to look at for the definitions of these?
If you look at chart 2.1.
2.1.
And then you can also look in the glossary. So sometimes the glossary might have a little bit more of an explanation, but you'll see down at the bottom, it says transcendentals are not roots of a finite polynomial with integer coefficients. So, okay, there was one more question.
Yeah, I wanted to know, am I understanding correctly that the way you modeled this with us today is how we will do it as directors in class, where the students will be filling in actually into the workbook as we go over this in class, and we just kind of touch the tops, and then ideally at home, they will complete those first 4 pages, ideally with a parent, like on Tuesday or like the next day after community, whichever community day that is.
That is the goal, is that you are going to introduce those first few page tops. If you have time, you're going to encourage them to, in class, go ahead and do some other page tops as time allows. And then, yes, at home, they would go ahead and complete those pages at home with as much parent help as they need.
Great.
All right, well, we are at the end of our time. So if you have questions, feel free to email the mathmap@classicalconversations.com or check out the forums. A lot of questions are answered there. So that's another great resource. And I look forward to next week when we talk about comparison.
Thank you so much, Christy.
Have a great day.
You too.